Welcome to the video once again. Okay, so we have this question here. A home has a television set rated 40 watt that is used for 10 hours a day, a hot water geyser rated for 4000 watt used for 3 hours, and a cooker rated 2000 watt used for 2 hours a day, all connected in parallel to a 240 volts power supply. First question: draw a circuit diagram to show how three appliances are connected. Okay, so remember, this circuit diagram that we are drawing has all these home appliances arranged in parallel. So this circuit diagram is going to have these things arranged in parallel. So I drew it in advance in order to just reduce on the time that we are going to spend. So what you must understand about this circuit is that these home appliances are drawn, or they are arranged in parallel. This is how you arrange things in parallel. And on top of that, guys, I'd also put the voltage, which is also put in parallel. It's arranged in parallel. And we also have the ammeter here, which is measuring the current. It is arranged in series. We also have the power supply here and a switch. So when you do all that, you get about 3 marks. Let's go to B. Okay, so B, A we've already drawn. So let's go to B. Calculate the power used by 3 appliances. So B, we're calculating the power. So what do we have? We have 40 plus 4000. We also have 2000. So just sum this up, and then you're going to have your total power. Okay, this is 40 watt. Okay, as simple as that. That's why it is 1 mark here. Calculate the power used by 3 appliances. So just sum up these 3 appliances and then you move on. Let's go to C. If electricity costs 20 ngwe per kilowatt hour, calculate the cost of using these 3 appliances in a day. Okay, so they have given us the electricity cost. So we are on C. What are we going to do for us to calculate the electricity cost? So we're going to begin with this one. This is the television set that was rated for 40 watt. So we're going to start with the television set. So we're going to calculate the energy that this television set was consuming in a day. Okay, so we're going to say energy is equals to power multiplied by the time. Okay, so remember, they have told us that the electricity cost here is 20 ngwe per kilowatt. So and then this is in watt. So we are going to convert this 40 into kilowatt. How do we do that? We're going to divide the power by 1000. So in short, I'm going to do this. So this is the power, which is 40 watt, and then I'm going to divide 1000 in order to convert it into kilowatts, and then I'm going to multiply by time. How much was the time that it was used a day? 10 hours. So I'm going to put the 10 hours here. So okay, so this 0, that 0 goes, this 0, that 0. So you're going to have 0.4 kilowatt per hour. Okay, so like this. Okay, I'm going to write it like this: 0.4 kilowatt hour. So I've converted this 40 watt into kilowatts. That's why you're seeing the kilowatt here. It was, at first it was in watt, and then the time, hour, is representing the 10 hours of time that it was running in a day. Okay, for 40 we are done. Let's go to calculating the energy for this. This is the geyser. water geyser. It was rated for, okay, I'm going to use the same formula. Okay, it was rated for 4,000 first watt, and I'm going to use energy is equals to PT. Okay, okay, so I'm going to say energy is equals to power. It was 4,000. Okay, multiplied by, for how long did it work in a day? 3 hours. And then I'm going to divide 1,000. So 1 2 3, 1 2 3, and then 4 will be multiplied by 3, which is going to give us 12 kilowatt hour. Okay, so right now I'm just calculating the energy. Okay, and then after that we're going to calculate the electricity cost. So let's go to the 2000 one, which is 2000 watt. Okay, 1000 watt. So I'll use the same formula. Energy is equals to power multiplied by time. Okay, so the power here is 2000, which is going to be divided by 1000 so that we can convert it in kilowatt. And then how much was the time that it was running? 2 hours. So I'm going to write the 2 there. Okay, 1 2 3, 1 2 3, 2 times 2 is going to give us 4 kilowatt hour. So I have calculated the energies that these appliances were consuming in a day according to the number of hours that they are running. So therefore I'm going to find the total. So I'm going to say 0.4 plus 12 plus the other one was 4. Okay, which is going to give us somehow, when I add these things, I'm going to have 16.4 kilowatt hour. Okay, so this was the total energy that these appliances consumed a day. So if you've seen, I started by calculating their respective energies that they were consuming, okay, in their respective time. This one was running for 3 hours or 10 hours, this one for 3 hours, this one for 2 hours. So after doing that, you can now say amount, okay, amount is equal to energy multiplied by costs. Okay, how much is the energy? Energy is this one that we have calculated. So the total energy for all the appliances, 16.4, multiplied by the cost. How much was the cost? They're saying the cost was, if electricity costs 20 ngwe per kilowatt hour, so we have 20 ngwe. And remember, in Zambia we use the kwachas when we are calculating the cost. So we're going to convert the 20 ngwe into kwacha. Okay, so I'm going to use this space here to convert. Okay, so I'm going to say 100 ngwe is equivalent to 1 kwacha. So how much ngwes do we have? We have 20 ngwe, which we want to convert into kwacha. So you're going to cross multiply 100. Okay, 100x is equal to, multiply this one by that, 120 by that. I'm going to have 20, and then I would divide 100 throughout, so that this and that. Okay, that and that. I'm going to have 0.2 kwacha. Okay, so I've converted the ngwe into kwacha. So instead of putting 20 ngwe, I'm going to put here 0.2 kwacha. So remember to convert the ngwes into kwacha. Okay, so after doing that, I'm going to multiply 16.4 by 0.2. So after I multiply, I'm going to have something like this. Okay, this is I'm going to have 3.28 kilowatt hour. So this is the electricity cost. This is the electricity costs. Okay, let's move on. Okay, let's move on. So this is electricity cost. So what else do we have here? What else do we have? The same on D. Okay, let's move on to D. Okay, calculate the electrical energy used by the television set in the period stated in C. Calculate the electrical energy used by the television set in the period stated in C. So we want to calculate the electrical energy used by the television, which we have already done, which we have already calculated. So the energy that the television set was running was 0.4 kilowatt hour. If you want, you can redo it again. So you can just say energy is equal to power multiplied by time. So how much was the power? We already converted it into kilowatts. It was supposed to be 40 watts, but we converted it into kilowatts. So we are having 0.4 multiplied by the time, which was 10. Okay. Okay. No. Okay. So let's do this. Okay. So the power was 40, and then we multiply by the time, and then we divide it by 1000. Okay, so this was 40 watt. When we divide 1000, we are converting it into kilowatt, and then when we multiply it by 10 is representing the time. So in this case, we are calculating for energy. So after doing that, 2 1 2, we are going to have 0.4, okay, joules. Okay, we're going to have 0.4 joules. Okay, so that is the energy. Okay, so forgive me guys, so even here on C, the energy was supposed to be in joules. Remember, the units for energy are joules. So everywhere where we were calculating for energy, we were supposed to put them in joules. So this is 0.4 joules. So we've calculated for energy of a television set. Okay, let's move on. Let's move on to E. Okay, E. The saying suggests a fuse rating suitable for the geyser. Suggest a fuse rating suitable for a geyser. So the geyser is rated 4000 watts. So how are we going to calculate for the fuse rated, the suitable fuse rating? So we're going to say power is equal to VI. Okay, we're going to use the formula for power. Why? Because we have the power and then we have the voltage. So now we are going to calculate for current. Okay, so the power that we have was 4000. Remember, this time around we are not converting it into kilowatts, we're just going direct. So 4000 over 4000, and then we have watts, which was here this is 240 watts. It was given in the question here. It was given in the question. So we're writing the 240 watt, okay, multiplied by current. Okay, after doing that, we're going to have 4000 equals 240 I. So let's divide 240, let's divide 240. Okay, so that one goes. Current is going to be excuse me, is going to be 16.7 amps. Okay, that's the current, but this one is not a suitable fuse. Okay, so remember, if you want to set up a fuse, okay, a suitable fuse, the current should be, a fuse should have more higher current than the usual one that is passing through the current. So this is the current that is going to pass through the fuse. So we're going to suggest, okay, therefore the suitable fuse rating is going to be maybe 17 amps or 17.5 amps, but I choose to settle with 17 amps as a suitable fuse rating. So this one is the one that the examiners are going to mark, not this one. This is the current that is passing through that fuse. Okay, now you need to suggest the suitable fuse that is not going to be destroyed when this current passes through it. So we are going to get the one that is a bit higher than this one. If you need further clarification, guys, please, you can drop your comments and I'll be there to respond. Thank you very much.